In today's lesson, we're going to talk about inscribed angles. An inscribed angle has its vertex on the circle. Yesterday we talked about central angles where the vertex was at the center of the circle. So with an inscribed angle, like angle BCA, its vertex is at C, which is on the circle. The measure of an inscribed angle is equal to half the measure of the intercepted arc. So if I know that arc BA measures 44 degrees, then I know the angle BCA is 22 degrees. An easy way to remember this is to take a look at the relationship between a triangle and a circle. A circle has 360 degrees, while a triangle has 180 degrees. So the triangle has half the degrees that the circle has. So all the inscribed angles will measure half the measure of the intercepted arc. If we wanted to go the other way with it, the circle has twice as many degrees as the triangle. So all the arcs will have twice as many degrees as the inscribed angles. And this problem right here, we are given the measure of an arc on a circle and asked to find the measure of an inscribed angle. So we need to remember that the measure of the inscribed angle is half the measure of the intercepted arc. So when I'm given that arc CB is 80 degrees, I'm able to conclude that the measure of angle CAB is 40 degrees. When I'm given that the measure of arc CB is 64 degrees, I'm able to conclude that the measure of angle CAB is 32 degrees. When I'm given the measure of arc CB as 126 degrees, I conclude the measure of angle CAB is 63 degrees. Or if I was given the measure of arc CB as 90 degrees, I conclude the measure of angle CAB is 45 degrees. And the reason for that is the measure of the inscribed angle is half the measure of the intercepted arc. We can go the opposite way with that as well. We could be given the measure of the inscribed angle and asked to find the measure of the arc. So if we're given the measure of the inscribed angle and we have to find the measure of the arc, we double the measure of the angle. So if I'm given that the inscribed angle measures 70 degrees, the intercepted arc is 140 degrees. If I'm given the measure of the inscribed angle 60 degrees, I double it to get 120 degrees for the arc. If I'm given the measure of the inscribed angle is 50 degrees, I double it to get the measure of the arc to be 100 degrees. If I'm given the measure of the inscribed angle is 46.5 degrees, then I can double that and determine that the measure of the intercepted arc is 93 degrees. Again, in today's lesson, the type of problem that you're most likely to see is going to be a little bit more involved than just doubling or dividing by 2. You're going to be required to use a little bit of extra thought. So in this problem right here, we have a triangle inscribed in a circle, triangle ABC. We're given that the measure of angle A is 68 degrees, and we're given that the measure of arc AC is 130 degrees. From here, we can choose to do this in any order we want. So one thing that we might do is we might say to ourselves, you know what? I'm going to find the measure of angle B. Angle B is an inscribed angle because its vertex is on the circle, and its measure is half the measure of the intercepted arc. So if I take 130 divide by 2, I get 65 degrees. Now a triangle has 180 degrees. So if I add 68 and 65, that gives me 133 degrees. If I take 180 and subtract 133, that leaves 47 degrees for the measure of angle C. If I wanted to find the measure of arc AB, I know that the arc has to be twice the measure of the inscribed angle. So if I take 47 and double it, that gives me 94 degrees. If I wanted to find arc BC, I know that the measure of the intercepted arc has to be twice the measure of the inscribed angle. So if I take 68 degrees and double it, that gives me 136 degrees. Then all that I need to do is just fill in the blanks based on what I have written on the diagram. So good luck with today's homework assignment on inscribed angles.